Hi, my lovely psychology students. Here is your second session on inferential statistics. And in this session, we're going to be focusing on the sign test. Now, when it comes to inferential statistics, each inferential statistical test has a set criteria. And this set criteria is specific to that test, but what makes it so nice is actually there are three simple questions that you can ask that will help you choose the right test. And also these three questions that you're asking become your justification why you chose that. So in order to work out which test, you ask, what is it measuring? Is it measuring a difference? So for example, between men and female, or is it an association? Is it looking for some form of relationship between covariables? Second question, what is the experimental design of this research? Now, please note, experimental design, so it can only be used really in the sense if it's looking for a difference, not if it's looking for a correlation, right? Because then it will be a correlational type of design that you would use. So experimental designs, you know what they are. That's right. Repeated measures, matched pairs, and independent measures. And the final one is, what is the level of data? So these three questions will help you choose which inferential statistical test, but it also becomes your justification. For example, I chose this test because it uses matched pairs design, it uses ordinal data, and it is looking for a difference between two key things. Now, you might be saying to myself, okay, pretty simple so far, but you've probably highlighted the question, Miss, what do you mean by what is the level of data? Never fear, I am here to explain that. Now, some of you will probably already know levels of data, but we have three levels of data that we work at, even though there are more, but we only focus on three. And the level of data means it's what we can actually do with the actual data that we have. You know, how accurate it is. Is it just very basic, or is it more accurate and that means we can do more things with it? So our first level of data is known as nominal data. Now, nominal data is the most simplest form of data that you can get. It can only be placed into categories. You either passed or failed your driving test. We don't have any other information. We don't have any scores, just that you passed or failed. Or whether you've got blue or green eyes, or you're tall or short. You know, we don't have tall or short. We don't have any measurements. All we know, we've got some tall people and we've got some short people. So really it's the most simple, and this is known as nominal data. So the only thing you can do with it is place it into categories. Our next level of data is called ordinal data. I like this one because ordinal, order. Remember, simplify the word. And this is the level of data that is a little bit more sophisticated than our nominal data. And actually, we can place this data in order. We can rank it. You all know what ranking, who came first, second, third, fourth. We know who came first, but perhaps somebody ran a race, but nobody took the timings, but we could see who came first, second, and third. So we can rank them, but we don't have a lot of detail with the data, but all we can do is, yes, we know that was first, second, third, or fourth, but we don't know perhaps if it was running a race. We don't actually have the actual times with that one. So it's ordinal, we can rank them. The third type of level of data that we're going to look at is called interval data. And this is a much more sophisticated type of level, and it allows us to do a lot more with the data. This data comes in numerical form. So actually we have, for example, the timings in seconds or minutes. We have measurements of height in inches and feet. So it actually comes with a numerical value. And this numerical value is standardized. And what that means is that if we're looking at centimeters, between 1 centimeter and 2 centimeters, there's 10 millimeters. If we looked at the idea of between 10 centimeters and 11 centimeters, it's still 1 centimeter and it's still going to have 10 millimeters in it. So really, it's got the same standard of size, so we can be a lot more accurate. Now, don't panic about ordinal data yet and interval data if it's not making sense. What we're focusing on today is this idea of nominal data. The most simplest form of data, all we can do it is place it into categories. We don't have any more. We just know, like, for example, in class, if I asked how many of you had brown eyes, how many had blue, how many green, okay, some of you may have hazel, and some of you feel that you have turquoise, you know, everyone has their own. But all we'd be able to do is say, well, there were 6 people, there's 7 people, and that's all. We can just place them into a category of the different colors of eyes, because we don't have any more information. So that's the one we're focusing on now, is nominal data with regards to the levels of data. So let's look at our sign test. Sign test is the first inferential statistical test that we're going to do, and actually it's the easiest. When we go through it, you might kind of think, oh, it's quite complicated, but I am going to give you a couple of worksheets for you to work through, and actually you'll see how quite easy it is. Now, the sign test, the criteria. Remember, we've got those 3 questions. What's it measuring? A difference or an association, experimental design, and the level of data. So the sign test is used when we're always measuring a distance, a difference, right? So sign test, we can't use it for an association. It's only used when we're looking for a difference. It can only be used as well when we use repeated measures design. Now, you know, repeated measure design, that means each participant does every single condition. So it's the same participant doing all the conditions. Third criteria, level of data. Remember, that was one of our questions. It uses nominal level only. Can't use any other level, just pure nominal level. So really, that's our criteria. And if you were asked a question in the exam, justify your choice of sign test, you'd say, well, it was measuring a difference, and you'd talk about the 2 conditions. It uses repeated measure design as the participant completes every single condition, and it only uses nominal data because the data can only be placed into categories. So those 3 questions help you choose the right test, but it also becomes your justification. So it's really important to make a note of that. So sign test, that's our criteria. Here we have lovely exam question I've taken from it, and I'm going to work it through because I thought it might be easier working through an actual example so you can see the process than just talking you through the process. So a researcher was interested in the perception of odor. He wanted to investigate the question of whether people experience different smells more intensely when they are blindfolded and then when they're able to see. 15 participants were asked to rate the strength of the odor on a 9-point scale under 2 conditions, blindfolded and non-blindfolded. Right, and below, in a minute, you'll see the findings. But before we get there, you know, I'm going to get you to do something else. I would like you to write a suitable one-tailed hypothesis for this study and write a suitable null hypothesis for this study. So in a moment, you're going to pause and then you're going to do this. Please do this, because in one of your papers, you're kind of guaranteed to write a hypothesis. Majority of the years, there's always a hypothesis. So practice makes perfect. Yes. So let's pause it here. Come on, pause it, write the hypotheses. You can do this. Right, good stuff. I trust and believe that you've wrote the hypothesis. Here we've got 2 simple, you can do a comparison. The rating of a standard odor will be higher when participants are blindfolded than when they are not. Keep it simple. Be direct. Remember, you need to have the 2 IV conditions. The IV is what? Blindfolded or not blindfolded. The DV is the smell of the odor. The odors, that's what we're measuring. If we're writing our null, There is no difference between the rating of order when participants are blindfolded and when they are not. I haven't put it on this one, but I do like to, if there is any difference, it is due to chance. I always like to put that on our null, good null hypothesis etiquette. Right. From the STEM, you would have picked up the IV and the DV, and remember, you've got to include both settings of the IV in your hypothesis. Right, so we've got our hypothesis, we've done the research, and we are now going to be working out our sign test. So again, just to reiterate, the difference is between blindfolded and non-blindfolded. Experimental design, it's repeated measures design. Each participant does both conditions. The level of data, it's nominal because there's two categories, blindfolded and non-blindfolded. Right, so a nice little recap so we clearly ought to see. So we've done our research, and here we have a lovely raw data table. Right, so once we've got all our results, we create a raw data table. We've got 15 participants, condition A, non-blindfolded, the results, and condition B, blindfolded. So we've got the two conditions. Now we're going to use this data to work out the calculated value of S. Remember, it's called the calculated value. Can you remember the other term it could also be known as? Yes, the observed value of S. Observed value means it's what you've done. Calculated value, you're doing the calculation. So it's what your data is calculating. So we've got our raw data. So we'll bring it back there. Right. So we're going to do this in stages, and I'm going to work through with you, right, as we go along. Remember, as we do each stage, you can pause it, do the bit of the little bit of the calculations, and then carry on. Or you can just watch the whole thing and then go over it again. So step one. Condition A, take away from condition B. Quite straightforward. Condition A minus condition B for each participant. Cool, so quite straightforward. So 4 minus 6 gives us minus 2. 1 minus 4 gives us minus 3. I'm not going to go through each one. You know, 1 minus 6 gives us minus 5. 3 minus 8 gives us minus 5. 7 minus 0, 7 not 0 gives us 0. So we first column, take away this second column. So we've done this calculation. Step one, condition A, take away condition B. Step two, now, don't get confused on this step. You add up the number of plus signs and give it a total, and the number of minus signs and give it a total, but not the actual scores, just the signs, right? But also you have to ignore the zeros. And the reason why we ignore the zeros is because if we look at participant number 7, in condition A, they got 7, and condition B, they got 7. And if we do the subtraction, A minus B, it'll give us 0. So actually haven't generated as any valid data. So we just ignore them for now. Now, please note, we do not total up the numbers, just the numbers of signs. So for example, if I look, I've got, that's 1 minus, 2 minus, 3 minus, 4 minus, 5 minus, 6 minus, 7 minus, 8 minus, 9 minus, 10 minus, 11 minus signs. So I have 11 minus signs here. So total of minus signs equal 11. We're not interested in the actual difference, the 2, 3, 4, 1. We're interested in the actual signs. So we do that again. So let's go through it again. Minus, minus, 1 plus. Ignore the zeros. So really, total numbers of plus signs equals 1. Remember, we're not interested in the actual differences, just the signs. So that's where students get confused. They total up the actual numbers and then they wonder why they get the wrong answer. We're just interested, because remember, this is a sign test. It's only interested in the signs. So step 3, we now need to work out the calculated value of S. You take the sign with the smallest amount. So we've got 11 as the minus sign and 1. So simply, we have now worked out the calculated value of S because it is the smallest one between these two. And obviously, S, the smallest is a plus sign, so S equals 1. So the calculated value of S equals 1. There we go. We've done the calculated value or the observed value. Yeah, hands up, shouting, hooray! Right, okay. So we've got the calculated value of S, it's 1. Pretty straightforward. Now, there's a few more things that we need to do. And next, we need to work out N. Now, N is the number of valid results that we've got, or the number of participants who generated valid results. So we need to work out N. Now, remember, in this test, we ignore the zeros. We don't want them. They didn't generate any valid data, so we've got to eliminate them. So what we now need to do, we know there was 15 participants and there were 3 zeros. As we can see, where's my mouse? 1, 2, 3. Yep, 3 zeros there. So what we do is N equals 15 minus 3, which equals 12. So N equals 12. So that means we have 12 valid sets of results. So we need that. Okay, we've worked out the calculated value of S, and we worked out what N is. Remember, if it's not making sense, rewind, go over it again. Now, in your textbooks, or even in exams, if you're asked to do because this calculation, the sign test, is the one calculation that they can ask you to do from start to finish because it's not that difficult. In any of the other inferential statistical tests that we do, you will not be asked to come do it from start to finish, but in this one you will. So if you are asked to do it, in the exam, they will give you the critical value table. And remember, this is a critical value table. We've learned what the critical value was in our first session, just looking at some of the key concepts. Critical value table has been created by mathematical statistical people, right? Statisticians, forgot their name there. So we don't need to do any calculations here. You will find this one in your textbook on page 198. So this is our critical value table. We know S equals 1, that's our calculated value, the one we've just worked out. We know N equals 12, the number of valid results that we got. Now we need to work out if we have found significance. And remember, if we can find, or we don't find significance, this will influence what conclusion that we make in terms of our hypotheses. So for the sign test, this is really important. In the sign test, the calculated value of S must be smaller or equal to the critical value. So it must either be smaller than or equal to the critical value. So the one that we've just worked out must be smaller than or equal to the one that we're going to get from the table. If it's bigger than, then we haven't found significance. If it is equal to or smaller than, then we have found significance. So let's move on. Now, let's look at the table. 1, column N. That's where we need the N because we'll go to number 12 there, right? So N here, there we go, we can see it there. And number 12 is really important. Now, it's also really important to know whether the research was a one or a two-tailed. Remember, one directional, two-tailed, non-directional hypothesis, because that will influence, if we look up top here, level of significance for a one-tailed test, level of significance for a two-tailed test. So it's really important that you know which type of hypothesis that we have. So which one can you remember? Yes, that's right, it was a one-tailed hypothesis. Now number 3, level of significance. Remember, P equals 0.05 or 5%. So here we can see, if we, find my mouse again, level of significance for a one-tailed, this is the column we're interested in because it's 0.05, that's 5%. We don't want 0.025 because that's 2.5%, or 0.01, that's 1%, or 0.005 because that's 0.5%. We want the 5% one. Can you see why it's important to get the right type of hypothesis? Because if we just took this one, the level of significance, and we used this wrongly and used the two-tailed test, can you see that column, which we're going to use the 5%, is actually now 10%. So therefore we would get the wrong critical value. So we need now to be in the 5% column. We go to 12. So where these two join is 2. So our critical value that we are now going to find is 2. So critical value of S is 2. 12 is N. We know it's 5% for a one-tailed hypothesis. So therefore our critical value of S equals 2. Now that we've got that, and remember we're trying to find significance, so the calculated value must be smaller than or equal to the critical value. So let's put it into terms. 1 smaller than equal to 2. Is that true? Yes, it is. So we have, if it wasn't, if we had 3 smaller than and equal to 2, then actually, no, we haven't found significance because the calculated value is bigger and it's not equal to. So that statement would not be true. But in this case, our calculated value is 1, the critical value is 2, and yes, we did find significance. So what does that mean? That means we can actually make a conclusion about the hypotheses. So how do we present our conclusion? Quite straightforward, and there is a statement that you'll have to get used to writing, and we'll use this type of statement in all our inferential statistical tests that we do. And it sounds like this, if it decides to come up. There we go. Significance was found as the calculated value of S equals 1 for a one-tailed hypothesis when N equals 2 and P equals 0.05. Is smaller than or equal to the calculated value of S, which equals 2. We've got to put all that information in so they know exactly the level of significance, what N was. We need to tell them what the calculated value is. We need to tell them what the critical value is. So we've put that there. Next sentence. The alternative hypothesis is accepted and the null hypothesis is rejected. So this is the only time that we can accept and reject our hypotheses. We did prove what we set out to prove. So that's why we're accepting our alternative hypothesis. Stating that when a person smells an odor when blindfolded, it is perceived as stronger than when not blindfolded. So really, this researcher would have found significance. They would have had a high level of validity because they proved what they set out to prove. Now, I know this is a hang of a lot to throw at you and you might be a little bit overwhelmed, but work through this session again and have it next to you when you're working through the worksheets. I'm going to give you 2 worked examples for you to do to see how you get on. Remember, if something's not making sense and you've got questions, make sure you send me an email. Ask me the questions. Remember, no question is silly, right? And don't think that you're bugging me. Please, I would rather you ask me the question, because if you don't know the answer, and I've said this to you plenty of times, it can be the most difficult thing out there. Right, my lovelies, work well, and you'll hear me in the next session. Take care.